In the previous video, I told you that when we measure resistance, what the ohm meter actually does is apply 1 volt, and the current that flows is used to calculate the resistance, because after all, it's just a formula. So before starting this video, let's check if I was really telling the truth. How are we going to do that? Well, we'll use another multimeter to measure the voltage at the input of the ohm meter. We start on the 60 megohm scale, the maximum. It reads 11.5 megaohms. And look, it's not 1 volt, it's 0.55 volts. If I switch to the 6 megohm scale, since it actually has 11 megohms, it goes off scale, and we can see it outputs almost 1 volt, just as I said. On the 600K scale, 1 volt. On the 60K scale, again 1 volt. On the 6K scale, 1 volt. On the 600 ohm scale, the same. And when we switch to continuity mode, it applies almost 1.2 volts to test continuity. That means that when we check continuity, we're actually applying 1.2 volts to the circuit. When testing diodes and LEDs, it outputs 3 volts. A white diode doesn't show any voltage because it needs around 3.1 or 3.2 volts. With a red LED, the forward voltage is 1.78 volts, and in reverse, no current flows. A Schottky diode shows 0.14 volts forward. A 1N4007 diode shows 0.56 volts. And now, let's move on to the second part of the series. One thing I hadn't done yet was let current flow through my body to simulate different types of batteries. But since anything under 12 volts generates very little current, it wouldn't be that interesting unless I force it through some internal areas. The tongue is perfect for that. When I was a kid, I tried this, and I wasn't the only one. But how much current actually flows? So, I connect a milliammeter in series to measure the current more precisely. First, I'll simulate a 1.5 volt battery. I got a current of 0.1 milliamps, and I didn't feel anything. Besides, 1.5 volt batteries don't have both terminals at the same height, so you couldn't touch them with your tongue. But those old 4.5 volt flat batteries, yes. I try 4.2 volts, which is somewhere between a 3.7V battery and a 4.5V one. I also test from my skin to my tongue. Interestingly, it doesn't feel too unpleasant, even close to 1 milliamp. With a 9V battery, though, it's already uncomfortable, reaching about 3 milliamps. If I put a red LED in series, it won't light through my skin, but it does through my tongue. I can't hold that unpleasant feeling for long, and the digital multimeter can't react quickly enough. I need an analog ammeter or an oscilloscope. Doing the math, touching a 12V battery with my tongue, which is actually a bit over 12 volts, could reach around 4.5 to almost 5 milliamps, which is quite unpleasant.
No! No, es molesto. Ay, es muy molesto.
And with a 24V battery on the tongue, the current would exceed 10 milliamps. That could already be dangerous. However, since the current enters and leaves through the same spot, the tongue, there's no real danger. Any damage would stay local. But if the current entered through the tongue and exited through another part of the body, it could become dangerous above 50 volts. Notice that human body resistance isn't constant as voltage increases. I mentioned this in the first part. I had calculated around 2,500 ohms, but at 24 volts, the tongue might be under 2,000 ohms. People often think no current ever flows through their body. But smartphones, for example, do let current flow through their touchscreens, although very little. They're capacitive, which means no steady current flows. The human body becomes part of capacitor, and once that area of the screen is charged, current stops. An ammeter can't detect such a tiny and brief current, only millivolts, and even then it's very quick. You can see it more clearly on an oscilloscope. At the beginning of the 20th century, the voltage tester was invented, what we now call a test screwdriver, which tells you which wire is live. By the 1960s, it used a resistor and a neon lamp inside the handle. Nowadays, it uses a LED. I've never used one myself because I always rely on a multimeter, but electricians often do. It's a very quick way to check. That's roughly the same as touching a 3-volt battery, because less than 0.2 milliamps flow. Inside, it has a 1 megohm resistor. We can actually see about 987 k ohms due to tolerance and a small neon lamp. This kind of tester doesn't work with direct current, only with alternating current. But that's a topic for another video. And speaking of another video, I'm going to make a third part of this series, because there's still more I want to add. Thanks for watching.